Now, what is a wave front? The pattern of waves produced after a stone is dropped in water look like the figures given, concentric circles known as wave fronts. But not all waves are circular. The sound waves are spherical. And I have other kind of waves, but this type of waves is known as wave fronts. The direction of travel of the waves is always perpendicular to the wave fronts. This is the ray. This is what we call a ray. We can have a light ray, a sound ray, anything. This is a ray. When a wave hits an object or a surface called boundary, four things can happen. The first thing is reflection. The wave bounces and goes in a new direction. I can also have a refraction. The wave bends as it passes into and through an object. Diffraction. The wave bends around an object or through holes in the object. And absorption. The wave is absorbed and disappears. So for your class, you only need to know reflection and refraction. We will see them further now. Reflection. When a wave bounces off an object, we call it reflection. A reflected wave is like the original wave, but moving in a new direction. So the wave bounces and goes in a new direction. As you can see, I have a wave going to this object and it's changing the direction. I have incident waves and I have reflected waves, and the wave bounces and goes in a new direction. Now, reflection does not change the speed or frequency of the wave, but the wave can be flipped upside down. This is the only change that is going to happen. The speed and the frequency of the wave will remain the same. Now, incident parallel waves are reflected as parallel waves. Incident concentric circular waves are reflected as concentric circular waves. So this reflection is not going to change the nature of the waves. If you have parallel waves, they will be reflected as parallel waves. If you have concentric circular waves, they will be reflected as well, the same. Incident and reflected waves have equal wavelengths, and therefore they travel with the same speed, as we said. And we are working in one plane, so I have 2 dimensions only. And the source of incident waves and that of the reflected waves are symmetrical with respect to the plane reflector. I'm sure you have seen that in the previous years. Now, refraction. Refraction occurs when a wave bends as it crosses a boundary. We say the wave is refracted as it passes through the boundary. So the wave is going to bend and will pass into or through another object. So if you look at the picture, I can see that this is the pencil, but since half of it is in one medium and the other half is in another medium, I will have the feeling that it is a split, or it's a different, it has 2 different parts, separated parts. The bending of a wave as it enters a new medium, this is what we call refraction. It is caused by a change in the speed of the wave as it moves from one medium to another. So in the refraction, the speed is going to change, whereas we said in the reflection, the speed and the frequency is going to remain the same. So greater change in speed means more bending of the wave. Okay, the index of refraction or refractive index. So refractive index, also called index of refraction, it's the measure of the bending of a ray of light when passing from one medium to another. If I is the angle of incidence of a ray in vacuum, the angle between the incoming ray and the perpendicular to the surface of a medium called the normal, and R is the angle of refraction, which means the angle between the ray and the medium and the normal, the refractive index N is defined as the ratio of the sine of the angle of incidence to the sine of the angle of refraction. Example, N equals sine I over sine R. Refractive index is also equal to the velocity of light, c, of a given wavelength in empty space divided by its velocity v in a substance, which is the formula that we will used, the most probably used this year. N equals C over V. C is the speed of light in the vacuum, and V is the speed of this wave in the specific medium given. N will be the refractive index, or the index of refraction. Okay, so I have here refraction. I have an incident ray coming from the vacuum, and I have the refracted ray going through a new medium. I have two angles. The angle of incidence, which is I, it's the angle made by the ray with the normal, and I have the refracted ray making an angle with the normal, which is R. So the refractive index, N1 and 2, I have two angles. You can call them theta 1 and theta 2, or I and R. And the index of refraction is N equals C over V. C, it's the velocity of light in vacuum, and V, it's the velocity of light in this specific medium that we are working in. Now, I have a refractive index. The vacuum is 1, the air 1.000036, the water 1.3, sugar solution 1.38, glass 1.5, and diamond 2.4. These numbers are going to be given, but you must know that the lowest refractive index is the vacuum, so 1. So all the others have a higher refractive index. And that's it. Thank you very much. Grade 10.